So let us try understanding linguistic hedges in this video. So what are these hedges? What do they do? So the first statement here says, so these linguistic hedges, they help us in modifying the values of linguistic variables. So what do they do and what are the implications of it? So what happens when you modify the values of these linguistic variables is they help us give out the truth of a statement more precisely. What do I mean by that? Let us look at a small example. Here I have a fuzzy statement called John is young, which is associated with a degree of truth 0.6. Now if I were to give you another small fuzzy statement, John is very young, and I ask you to calculate the truth value of it. So what you could do here is you could define a small function like this, which says, okay, if you were to like ask vary of something, you can square the previous truth value and then find out the new truth value. So that is what your hedge does. So it works on top of your truth values of your regular fuzzy statements, and then it gives out a new accurate truth value. Now why do I call it more accurate? Now consider a 15-year-old boy. So my original fuzzy set says that he is young. So this guy is termed as young. Now, can I call him as very young as well? Maybe not, right? So 15 can no longer be considered as very young because there are certain other people who can be called as very young. Maybe 5 is very young. Maybe 6 is very young. We definitely know that very young is a concentration to your young fuzzy set. If you guys remember concentration and dilation, this pretty much does the same thing. So what very does is it concentrates whatever you have here. So example for your hedges are very, more, fairly, so on and so forth. If you have a proposition x is f defined by p, and then you need to find the truth value of another proposition hp, all you need to do is apply this hedge. Hedge is your hedge to your fuzzy predicate. So f is your fuzzy predicate, so you only need to apply this hedge to your predicate. Now there are a few properties associated to these hedges. So it works as a unary operator over this interval 0, 1. So there is just a single operator. So all you guys need to remember over here is this part. So whenever you find very or something which accentuates the value of a predicate, all you got to do is think about ways to strengthen the predicate. Now a function like this, a square, definitely strengthens it, as I have already shown you. It gives you a smaller value. So this is equivalent to your concentration. So please do refer to that again in case you guys are confused about what I'm saying. So concentration, and fairly young says that someone is not really young. So all you guys need to do is think about a way to dilate this graph. So square root over a will definitely dilate it, as in it weakens the predicate. So dilation is what you are supposed to be looking at. So these were already discussed under the topic of fuzzy sets. So please do refer to those videos in case this is confusing to you. So anyway, there are a few more conditions associated to hedges. So hedge is always continuous. So whatever fuzzy set you are applying this on, it also needs to be continuous. And h of 0 is equal to 0, and then h of 1 is equal to 1. So if h is strong, then you obviously expect 1 by h to be weak. And then you can definitely combine 2 or more hedges to form more hedges. So that is all you have about hedges. Now let us look at our last part. Now G was used in our linguistic variables, but then I have never really defined it. So let us try understanding what G does. Now G has various other small parameters involved in it. It's present on your screen. So Vn represents non-terminal symbols, Vt represents terminal symbols, PR represents production rules, and then S represents star symbol. Now this G is used to generate new fuzzy predicate statements. Now why do we need to generate these new fuzzy predicate statements? In the previous case, we saw that we needed to find out the truth value of a new statement, John is very young, from John is young. Now this new statement need not again be referred to as a different question, but then it could be used as a modification of our original question. But then how many different such cases can we generate? Can we namesake generate whatever we want to? No, we cannot create such infinite ones. Now what restricts that? So G is the part which restricts the different kind of fuzzy predicates that you can come up with. So this sort of looks like a grammar. So you guys might have seen something like this in the case of compiler design, where you have rules and then production rules associated with it. So this looks something like that. So as I've already said, G has a few components. So S is one of them, the start symbol. Vn defines all the non-terminal members, and Vt represents all the terminal members, and in this case we just have a couple of them. We have young, so young is, so this is Vt, by the way. So the set of Vt is young and old, so just two of them. So these are the production rules that guard what valid statements we can have. So just have a quick look at it. So what we need to do is we need to find out if we can come up with new statements. So here there's a small phrase given which says not young and not very old. So let us see if we can generate this small phrase using this grammar, is what you can call it. So you can start off with your starting point, yes. So that's the reason we have the start symbol. So you start off with this S implies A, and from S implies A, you can also infer this part. Why? Because A again implies A and B. So the second part gives you S implies A and B from our third rule. And from this, you can also infer S implies A and not C. And this is from my sixth rule. And from this, again, I can say S implies A and not very C. And this is from my eighth rule. So this is where my C is implying very C or less C. So I'm using very C in this case. And from there, you can go ahead and then find out A and not very D. And not very D. Okay, so this is present in 7. From C implies D is where we are getting that. So C is replaced by D here. And now D, it refers to young or old. And since we are dealing with old here, I'll be using old. So now S implies A and not very old. And then I'll be replacing my A with B by using rule number 4. So now this becomes S implies B and not very old. And from B I can also infer not C. So I'll replace my B with not C. This now becomes S implies not C and not very old. And since my D is associated with young or old, I need to replace my C with D. So I'll use my rule number 7. So this becomes S implies not D and not very old. Now I can replace my D with young, use my rule number 10. So I'll get S implies not young and not very old. So this is just a case of random substitution and then finding out whether the predicate that you want to come up with is a valid one or not. So that pretty much sums up our entire syllabus for this AI. So I guess you guys had a good experience. So anyway, I'll finish up with a small assignment question. So I want you guys to try out this small exercise. So find out whether more or less young, whether this small fuzzy quantifier can like fit into this grammar. So that will be your fifth question in assignment number 3. So that is it. Thanks a lot.